Hello, hello. I'm back at my house today, and so it may be a little bit noisy. The dishwashing machine is running, but I'm right up here by the phone, so the volume should be pretty good. But today we're looking at 5.8b, graphing from standard form. Now the thing about standard form is we're going to have to get it into factored form in order to get our zeros to graph. And going from standard form to factored form is what's going to be the most challenging aspect of this section right here. It might be that you have to do the quadratic formula. You're most certainly going to have to factor, more than likely factor a quadratic. You may even have to do synthetic division, depending on the problem. So there's a lot of variability here, and you're going to want to practice. You're going to want to do your homework and make sure that you're not caught off guard by anything, and that you have a solid foundation in all the possibilities. So I'd like to start out here, 5.8b, graphing from standard form. I want to start out with an example, and we're going to do about 3 examples, each a little bit different, get you some variety. So we've already graphed from factored form. So here we start off with instructions to graph f of x equals x to the third minus 7x squared minus 28x minus 20. And here's what's interesting. Given that negative 2 is a 0. Now, if you tried to, if you weren't given that negative 2 is a 0, and you tried to factor this to get it into standard form, you would run into some issues fairly quickly. You do have 4 terms, so factoring by, well, let me back things up. First, check to see if you could factor out a monomial, because that could happen. But notice we can't factor out a monomial. If there was a negative out front, we would want to factor out a negative monomial and then go from there. But we don't have that situation here. If you tried to factor this by grouping, you'd find out that it would not work. So we're given a hint here. We're given that negative 2 is a 0. So what we're going to do is synthetic division to help us simplify this and find out what's left over. So we're told that negative 2 is a 0, so we'll put that off to the side. We write our we write our coefficients here: 1, negative 7, negative 28, negative 20. And then if you recall how synthetic division works, bring down the first one, multiply, add, multiply, add, multiply. And sure enough, we get a remainder of 0, which we knew would be the case because we were told that negative 2 is a 0, which means it'll divide into it cleanly. Now, what this is saying is we have a, let's see, constant x squared. We have a quadratic left over. Now, I want to get you the full picture of where we're at here. At this point right now, f of x is going to be equal to this quadratic here, and we're going to write this 0 as a factor. So we're going to write x plus 2 x squared minus 9x minus 10. So we've started factoring here. This turns out x plus 2 is a factor, leaving behind this quadratic. Well, it's not completely factored yet, so we want to keep moving. This is a quadratic, leading coefficient of 1. So all we need to think of are 2 numbers that multiply together to make negative 10, but add together to make negative 9. Negative 10 and 1 will do the job. So here's our factored form coming up. We've got our x plus 2. Then we're going to rewrite our quadratic as x minus 10, x plus 1. And now we're in factored form. So from here on out, this will be similar to what you've already done, the graphing you've already done from factored form. It'll be pretty straightforward. And in some aspects, it's going to be a little bit easier. So from our factors, we can write our zeros. Our zeros are going to be the one that was given to us, -2. And then we're finding it'll also be 10. And it'll also be -1. And all of these only showed up once. So at these zeros, they're all going to cross. Okay, it's going to cross there. We had no multiplicities this time. Or our multiplicities were 1, I guess we could say. Now what else do we need to make our graph? I mean, we could start to make our graph right now. Put dots at our at our zeros. So -2, -1, way over here at 10. Let me make sure we're going what we're going by here. 2, 6, 8. Ah, yeah, good. So there's actually 12 all the way to. Place our dots there. Well, we need our end behavior to know how to thread this thing. We also are going to find out our y-intercept to make our graph a little more accurate. It kind of helps us to determine our amplitude. So for end behavior, I'm going to look back up to my original problem. My degree was 3, so that's odd. My leading coefficient was positive. So odd degree, we think of a line, and positive, we think of a line going up. Now I don't really have to write it out formally to make a pretty good graph, but just for practice, we'll write this out. As x goes to the left, -infinity, the graph is going down. As x goes to the right, +infinity, the y value is going up, +infinity. So we've got our end behavior. Let's get that y-intercept, and then we'll be done. Or we'll be ready to graph, I should say. Our y-intercept is where x's value is 0. And I'm going to go up to the original problem. If I put 0 in for all these x's, it's going to wipe those out. We're going to be left with a -20. I don't think you have to show a whole lot of work there. Now that's significantly easier than in standard form, where if you put it in up here, you would have to put zeros in and then multiply what's the resulting. But just go up to your original problem, get your y-intercept there, and we're ready to do this. Okay, so our y-intercept is -20, and I've taught you guys just go beyond the graph and just write in -20. It's going to be pretty far down there, but this is good enough. We know that it's going to be going there quite low. Our end behavior says to start bottom left. So we're going to come up here, we're going to cross at each zero. So we're going to cross, quick turnaround, come down here, make sure to hit the y-intercept. Now our y-intercept isn't necessarily the turning point, so it's probably going to go down here quite a bit, gradually turn around and cross and go back through. So here we go. And down we go. Make sure to hit that y-intercept. And back up. And we've graphed this polynomial function from standard form. So to review, we were given a 0. When you're given a 0, go ahead and do some synthetic division, find out what's left over. And then keep factoring, keep solving for your zeros. End behavior, y-intercept wraps it up. Okay, let's try another one. Let's try another one. F of x equals x to the third plus 8x squared minus 7x minus 56. And our instructions are to graph that thing. We are not given a 0 here. Well, that means we should be able to solve it without it. And what I'm going to try to do since we have 4 terms, well, I first need to check, can I factor out a monomial? That doesn't have an x, can't factor out an x. All right, can't factor anything out. There's not a negative out front, can't factor out a negative. Always check that, because there are going to be instances where you do need to do that. But since we have 4 terms, we're going to factor by grouping. Now, before I factor by grouping, I like to make this a plus sign in the middle there. That way when I group it, I know I'm not making it a product. I'm not making it multiplication. I'm just grouping. And then in the front, I can factor out an x squared, leaving behind an x plus 8. Back here, I do have to factor out a negative, and it looks like a negative 7. Leaving behind, so divide to find out what's left behind. X plus 8. So it does factor by grouping, I know, because these match. So I factor out the common binomial, x plus 8. That leaves behind x squared minus 7. Now you may be thinking, this is x squared, it's got a minus, maybe this will factor on down. Well, it doesn't, because 7's not a perfect square. If it was a perfect square, we'd go, x plus, x minus, and we'd be in good shape. And that will happen sometimes, but not in this instance. So this is as good as we've got it for right now. So I'm going to write f of x equals x plus 8, x squared minus 7. That's our factored form. Or as factored as we're going to do it. You can factor it using I, but you're going to see how that works out here in a second. Okay, now that it's in factored form, we get our zeros. Well, one of our zeros is going to be negative 8, no problem. But this 0 is not going to be 7, so take a look. When we get our zeros, we're actually setting each factor. We're doing the zero product property. We're setting each factor equal to 0. Okay, this is the full story that we don't always show. So that's where we're getting minus 8, is because we're subtracting 8 over. But on this one, because of that x squared, we got a little extra work to do. So you are going to add the 7 over. But then how do you undo the squaring to get x? Well, you square root. When you square root, you need to make sure to put plus or minus. So our zeros here are going to be plus or minus square root 7 and a negative 8. Well, square root 7, I prefer to write it as a decimal. It'd give me a better idea of where this goes. So I'm going to grab a calculator and write those zeros out as decimals. So we've got x equals negative 8. We're going to have a positive. We'll just round it to the nearest tenth. It'll be, let's see, 2.6. That's the positive. And we're also going to have a negative 2.6. So class, remember, x squareds will pop up in here when you solve square root. But don't forget plus or minus. You're going to have 2 solutions there, one positive, one negative. All right. The multiplicity on these, they all show up once. Yeah, we got 2.6, but one's positive, one's negative. So it's going to cross at all these. Our end behavior, because it was odd and it was positive, again, we're thinking of a line going up. And our y-intercept is where x's value is 0. And let's go back up to the original problem. 0, 0, 0, negative 56. And that's way off our chart, so we'll just go down here, make a mark, negative 56, put a dot at it. Our zeros are at negative 8, 2, 4, 6, 8. Negative 2.6, positive 2.6. Our end behavior says to start down low. We're going to cross at each 0. So we cross, come back down, cross. Make sure to hit that that y-intercept, it looks like it may be pretty close at the turning point. It's kind of halfway in between, so I think that will be pretty close. I'll turn around at that and come back up, and we're good. And there we go. So class, one of the biggest things that I can't stress enough is right here when you solve for that x squared, plus or minus, plus and minus, you need to have that. Please don't forget it. It'll throw off your graph and your end behavior won't make sense and you'll be all confused. And it turns out it's just because you forgot that there's a negative answer as well. So keep that in mind. All right, let's flip it over. Let's do one on the back here. We may not graph it, but I just want to get you some more variety because, well, in standard form, a lot of things can happen at the very beginning. So let's go. We're not actually going to graph it all the way, but we'll start it out, okay? We're going to graph g of x equals -2 x to the 4th plus 4x squared minus 8. We are not given a 0, so we're not going to do synthetic division. But we always need to check and see if we can factor out a monomial. And in this case, we can. And not only will we factor out a monomial, we will factor out a negative monomial. Whenever there's a negative out front, we need to factor out a negative. So I'm going to write this as g of x equals -2. We'll go into everything, leaving behind x to the 4th. Divide 4 by -2, we get -2x squared. Divide, we get +4. So we factored out a monomial, and then we're tasked with factoring this out right here. Now notice this is not a quadratic, is it? But with that 2 being half as much as that 4, this is quadratic form. So we're going to factor it like a quadratic. Because there's a leading coefficient of 1, we just have to worry about that 4 there. So what two numbers multiply together to make 4, but add together to make -2? And wouldn't you know it, class? It doesn't factor. So actually, this problem was I probably made it up at some point, but it doesn't factor. We'd have to do something else to figure that out. We could do some kind of probably quadratic formula to do it, but it'd be a little bit tricky because we'd have x squared that we'd be solving for. But my big purpose of this was showing that sometimes you will factor a monomial first. And you know, maybe next time around I'll make one that actually factors once you put it in quadratic form. That would have been helpful. Well, hey, that's it for me. Hey, your homework for this is 5.8b handout. Practice, practice, practice. Keys on Canvas. Hey, thanks so much. Have a great day.